everyone, and welcome to your first Chemistry 124 practical demonstration video. Practical 1 is divided into two parts. In part 1, you will determine the concentration of an unknown sodium chloride solution by making use of density and a calibration curve. And in part 2, you will prepare your own sodium chloride solution of a specific concentration. Let's get started.
Determining an unknown sodium chloride concentration. In the first part of the practical, you are going to determine the concentration of the unknown sodium chloride solution by making use of the density and calibration curve that is provided. You will also investigate and compare the accuracy and precision of three different types of measurement apparatus, namely a measuring cylinder, a burette, and a pipette. The process will be conducted in triplicate, and the average of the three masses from the most accurate apparatus will be used to determine the density of the unknown sodium chloride solution. Remember, density is the mass of a substance per unit volume. The density value of the unknown sodium chloride solution can then be used to identify the concentration of the sodium chloride solution according to the calibration curve. You will need one 600 cubic centimeter glass beaker for the collection of the unknown solvent, three 100 cubic centimeter glass beakers for the triplicate experiments, one 50 cubic centimeter measuring cylinder, also called a graduated cylinder, one 50 cubic centimeter burette, one 25 cubic centimeter pipette, one funnel, one pipette filler, the mass balance, also referred to as a weighing scale, 3 pieces of aluminium foil to cover the beakers, and the unknown solution. This can be found in large stock bottles placed centrally in the laboratory at the end of certain benches. To start, firstly, make a note of the temperature in the laboratory. Remember, temperature affects density. Secondly, pour approximately 300 cubic centimeters of the unknown solution from the nearest large stock bottle into your 600 cubic centimeter glass beaker. Weigh 3 dry, clean 100 cubic centimeter glass beakers after marking them as 1, 2, and 3 respectively. Make a note of these masses in your lab manual under measurement 1, 2, and 3 respectively. Measure 25 cubic centimeters of the unknown solution into a 50 cubic centimeter measuring cylinder and pour it into one of the 3 weighed 100 cubic centimeter glass beakers. Repeat this for the remaining 2 100 cubic centimeter glass beakers. Now weigh the beakers again and make note of the new masses. Record this under measurement 1, 2, and 3 respectively. This is a recording of your mass of the glass beaker and the water. Pour out the unknown solution into the supplied waste bottle, rinse it with water and dry the beakers using a paper towel. The paper towel can be found in the middle of the lab. Measuring with a burette. Rinse the burette as instructed and prepare the burette for use by filling it with the unknown solvent using a funnel. Remember, you don't need to fill the burette exactly up to 0.00 centimeters cubed. As long as you have determined the initial reading and a final reading, you can use these exact differences. add 25 cubic centimeters of unknown solvent from the burette into each of the 3 clean, dry beakers used in the previous part of the experiment with the measuring cylinder. Use this formula to calculate your total volume. Weigh the beakers containing the solvent and make a note of the masses as measurement 1, 2 and 3 respectively under the heading using a burette. Pour out the unknown solution into the supplied waste bottle, rinse your beaker with water and dry the flasks using paper towel. Making measurements with the pipette. Read the instructions for the use of a pipette and rinse a 25 cubic centimeter pipette as described to prepare it for use. Fill the pipette with unknown solvent to the 25 cubic centimeter calibration line marked on the pipette using a pipette filler bulb and let the solvent drain into the same dry glass beakers from the previous measurements. Weigh the beakers and make a note of the masses in your table as measurement 1, 2 and 3 respectively. Pour out the unknown solution into the supplied waste bottle, rinse it with water and dry the beakers using paper towel. In part 2, you will prepare a specific sodium chloride concentration. In the second part of the practical, you will need to prepare a certain concentration of sodium chloride solution by making use of a volumetric flask. From this known concentration, you will then be able to calculate the density from the measured mass so that you can compare it to the expected density according to the calibration curve. What you will need for part 2 of the prac is one 100 cubic centimeter volumetric flask, one weighing boat, distilled water, and the sodium chloride salt. Firstly, take a clean weighing boat to the balance, weigh its mass and record the mass in the table. Add about 8 grams of sodium chloride. Remember, it does not have to be 8.000 grams exactly, but it can be between 7.800 grams to 8.200 grams. Record the mass of the weighing boat and the added sodium chloride salt of about 8 grams. Weigh the empty 100 milliliter volumetric flask and record its mass in the table. Transfer the sodium chloride from the weighing boat into the volumetric flask using the funnel and add distilled water from the squeezing bottles provided to ensure that the sodium chloride is transferred quantitatively from the weighing boat into the volumetric flask. Do not use more than approximately 50 milliliters of distilled water at this stage. Then remove the funnel and close the flask. Shake and mix the volumetric flask well until all the sodium chloride salt has been dissolved. This step is very important. Then make up the solution to the mark on the volumetric flask. Do not exceed the mark. Ensure that the meniscus is sitting on the mark. In step 6, shake the solution well to ensure that it is mixed well, and then weigh the volumetric flask with the solution and record its mass. In the last step, once you have all of the required data, discard the solution in the correct waste vessel in the middle desk of the lab.